Hello and welcome. We are from Group 2 of Class 11 CHM256, and in this presentation, we will be explaining the volumetric analysis in cleaning agent. Before we begin, let me introduce the members of our group. This presentation was prepared by Nasir Nabilah, Ain Afrina, Nur Shakira, Aisyah Nadira, and myself, Khairi Nandra. Now that you have known all the team members, let's dive into the topic.
Volumetric analysis, also known as titration, is a scientific method used to determine the concentration of a specific substance in a solution. In the context of cleaning agent, this process is especially useful for identifying how much acid or base is present in the product. These components are the active ingredients to help break down dirt, grease, or other contaminants. To perform volumetric analysis, a solution of a known concentration, often called the titrant, is carefully added to the cleaning product, which contains the unknown concentration. This is done using a tool called a burette, which allows precise measurement of the liquid being added. A chemical indicator such as phenolphthalein or methyl orange is used to show a visible change, usually a color shift that signals the reaction has reached its endpoint. For example, if we are testing a basic cleaning agent, we might use an acid as the titrant. As the titrant is slowly added, it reacts with the base in the cleaner. Once all the base has reacted, the indicator changes color, letting us know that titration is complete. From the volume of titrant used, we can calculate the exact concentration of the active ingredients in the cleaner. This is important for several reasons. First, it ensures that the product is effective. If the concentration is too low, it may not clean properly. Second, it helps confirm that the product is safe. Too much acid or base can be harmful to skin, surface, or the environment. In summary, volumetric analysis is a reliable and accurate technique used in quality control to test the strength and safety of cleaning products. It combines chemistry with careful measurement to make sure consumers are using products that do their job well without causing damage or risk.
Next, for background, volumetric analysis or titrometry is a quantitative technique used to determine the concentration of substance by carefully measuring the volume of a known solution needed for a complete reaction. It is often used in labs to find unknown concentration through precise volume-based methods. In this study, we use acid-based titration, a method where a cleaning agent is treated like an unknown solution to investigate its active ingredients and determine how much acid or base it contains. Do you know there are three common types of titrations, which is acid-base, redox, and precipitation. Each one is used depending on what kind of substance we are analyzing. Firstly, acid-base titration, which is used to find out how much acid or base is in a solution by neutralizing it. And second, redox titration, which involves a color change and is used to study reactions where electrons are transferred. And lastly, precipitation titration, which involves forming a solid which is precipitate to find the amount of certain metal ions in a solution. In this study, we focus on acid-base titration, where the endpoint is determined by a change in pH, indicating that the cleaning agent has been successfully neutralized.
Next, continuing with the case study. Based on the previous slide, we will be using the acid-base titration for this experiment. For the first step, we will prepare our sample. We will be using toilet cleaners in this experiment, and we will dilute it appropriately with distilled water to ensure safe handling and suitable concentration for titration. The second step is we gather all the required tools and chemicals. We will be using burette, pipette, conical flask, pH indicator, commonly phenolphthalein, and a standard solution of known concentration such as NaO or HCl. The third step is we perform the titration. First, we accurately measure a known volume of the dilute cleaning agent using the pipette and transfer it into the conical flask. Next, we add a few drops of phenolphthalein indicator. Then, we fill the burette with the standard acid or base solution, depending on the nature of the cleaner. And then, we slowly add the titrant from the burette into the conical flask while swirling the solution until a visible and lasting color change occurs. Next, we record the volume of titrant used, and then we repeat the titration multiple times to obtain the consistent result and calculate the average volume of titrant required. So, the conclusion for the experiment is this method allows the quantitative comparison of the chemical strength of various household cleaners. By analyzing the titration results, we can determine whether a product is strongly acidic, strongly basic, weakly basic, or near neutral. Such information is useful for understanding the product safety, handling instructions, and appropriate usage in different cleaning scenarios.
During the titration, we observe a colorless solution at the start, but at the end point, a permanent pale pink color appears, indicating the natural pH. The pH level changed from strongly acidic to neutral, confirming that the presence of acid in the toilet cleaner. Some samples produce bubbles due to the reaction between NaOH and acidic component like HCl. So here is our result. Our average volume of NaOH is 24.43 ml. And in summary, the toilet cleaner has strong acidic pH, which is neutralized by NaOH in the titration. The calculated concentration of acidic is about 0.244 mole, confirming that its strong cleaning ability due to a high acidity.
So, to be concluded, titration and pH testing provide a simple yet powerful method to analyze household cleaning agent by determining their acidity, basicity, and concentration. This help consumer make informed choice about which product are most effective for specific cleaning tasks, while also ensuring safe use, especially when dealing with strong acid or bases. Volumetric analysis, often seen as a laboratory technique, proved to be highly relevant in everyday life, showing that understanding the chemistry behind common cleaners allow us to use them more safely, efficiently, and responsibly.
We hope you enjoyed our presentation. That's all from us. Thank you for watching.